Hello everyone, my student ID is 10503705. Today we're going to do a trace analysis for NAT with Wireshark. As we all know, NAT stands for Network Address Translation, and it is used to translate a set of IP address to another set of IP address. But we're still interested in the detailed translation procedures. So we will capture packets as both of the input and output wise of the NAT devices. We need to capture packets at two locations. In this video, I will use the MAC to connect the external network and share the network to the Kali in the virtual machine. That means the MAC will provide the NAT service for the Kali. And use Wireshark in both MAC and Kali to trace some file with the same payload and to compare them to find the differences. Now let's check in the IP addresses. This is the MAC system's IP address, which is the NAT service IP address. And this is the Kali system's IP address, which is the client IP address. And we'd like to choose HTTPS as an example. Let's start tracking in these two systems. I will log in the Google website by typing domains so that I can easily find the IP address of Google service by the DNS. There we go. We can capture the details now. And according to the DNS, we get the Google service IP address. Yeah, this is the Google service IP address. Then, let's use the display filter. We choose the encrypted payload as a field. Okay, search now. Okay, we can see that only one result for each Wireshark. Let's compare and find something different and interesting. Firstly, checking the IP address. This one is sending message to Google server, so the destination IP address are same. But we can see that the source IP address is totally different. That is the biggest difference in NAT. Secondly, we find the port address is different as well. Why? Why does NAT map the IP address and the ports at the same time? To answer this question, we have to tell you guys the types of the NAT. There are three different types of NAT. Firstly is static NAT, which is a one-to-one relationship between the private IP and the public IP. Secondly is the dynamic NAT, which allows unregistered private IP address to be translated into a registered public IP address from a pool of public IP address. Third one is a PAT. PAT is the most popular types and the simplest types among the three types. It is one form of dynamic NAT and is similar to it, but it maps multiple private IP address to a single public IP address by making use of ports. In this case, we use the third one. Okay, let's come back to the details. We can see that the third difference is the header checksums. The checksum of an IP packet is calculated over the entire header. Therefore, if the source or destination IP address or both of them has been changed, the checksum must be recalculated again. The same is true of the checksum in the TCP header. So we can see that the header is totally different after translated. And then let's focus on this sentence. Don't fragment. It means the package is not fragmented. We can use NAT to translate different local address based on the destination port. However, if the packets become fragmented, like the TCP or UDP header, which only containing the source and the destination port number is in the first fragment only. If a first fragment is translated firstly, information will be kept so that the subsequent fragments are translated in the same way. But if a fragment arrives before the first fragment, the NAT has no choice but to hold the fragment until the first fragment arrives and can be examined. So this message is really important. That means this is don't fragment. Maybe we can see other different in other different situations. A NAT is used to minimize the requirement of global unique IP addresses, allowing a host whose address is not globally unique to connect it to Internet by converting the address into global address spaces, which is rotatable. And also, the NAT decreases the vulnerabilities or security attacks at the private address prevents the public address from being exposed. Okay, that's all about the NAT. Thanks.